All right, this video is going to cover part A of the self-divisor free response question. And I think a big part of this is to understand the question, right? So something is considered a self-divisor if all the digits in the number evenly divide the original number. So just to make more sense of it, they give an example of 128. 128 is a self-divisor because if we take the digits one at a time, so we take 8 and we divide it by 8, that comes out evenly. Not sure exactly what that is, probably like 16 or something, so it comes out evenly. And then you take the next number 2 and 128 divided by 2, that definitely comes out evenly, right, to 64. And then you take the last digit 1 and 128 divided by 1 comes out evenly. Oops, should be 128, sorry about that. My brain was thinking something else at the time. Okay, so for something like 26, that's not a self-divisor because if we take the first digit 6 and try and divide 26 by 6, that does not equal a whole number. Okay, so this is a good review question because we're going to need a couple things, right? We've got to loop through the digits one at a time. In order to do that, you're going to need mod 10. That'll get you the last digit each time. And then if you divide by 10, it'll truncate it. So like for 128, I can do mod 10 to get the 8. Then take the original number divided by 8, right? And then see if that works out. If it doesn't, you're going to return false. If it does work out, then you're going to chop it by 10. So that would give us 12, right? And then you do mod 10 again to get the 2, and then check the 2 dividing against the original number, right? So one of the tricky parts about this one for me was I have to store this original number because we have to test it against our digit each time. Does it divide evenly? So we need to store the original number, and then we need another number that gets chopped down, right? And that's going to be our loop. Basically, while that thing is greater than, so this is a num we're going to update each time. Well, that num is greater than 0. We're going to keep doing these steps of get the last digit, check it, and then divide by 10. Okay, and at any point, if it doesn't work, we can return false, and the whole method will end. The while loop and everything will end as soon as we get a false. So sorry if you can't see that. This is going to be like a num variable that I'm going to use here. A separate one, different than the original number that comes in. Oops, now I get 2 greater than. Sorry about that. All right, so let's actually get to some of the code here in Eclipse. Okay, so basically we want to keep looping while we still have digits, right? Because we're going to do that mod 10 divided by 10 to get the digits one at a time. So basically I want to do while number is greater than 0. But one of the tricks I figured out here is that, again, we don't want to modify number because we need to check it each time, right? So we need this original number stored. Okay, so in order to get around that, what I did was I just made a new thing called like num equals number or something like that, so that we don't modify this original thing. So maybe I should call it original number, right? And then we can modify this number. Hopefully in the directions it says we can modify num. It can be changed. So at any rate, so now I want to do while number is greater than 0, and I've stored the original one for that check that comes later. So basically we want to get the last digit. So I'm going to do int digit, right? And there I'm just going to do number mod 10. So that'll get you the last digit. Okay, and then if that digit is a 0, right? So they said if it's a 0, then it always fails. Or if it doesn't evenly divide the original number, then we want to return false. So I'm going to do original number mod this digit. Okay, and if that's not 0, if it doesn't evenly divide, so basically mod again is remainder. So if I take the original number, divide it by the digit, and I don't get a remainder of 0, then it doesn't evenly divide, right? So that would be like the 26, where this digit, we do 26 mod 6, that doesn't come out as 0, so it means it doesn't evenly divide. All right, so if it is a 0 or it doesn't evenly divide, then return false. So sorry if I didn't cover that earlier, but in the question it says 0 isn't considered to divide anything even. So if you have a 0 at all, then it's not a self-divisor. So if the digit we're on is 0, return false. Okay. And so after the if check, then we want to just truncate number. So we want number to be what it was before divided by 10. So that'll chop off the last digit. So like 128 would become 12 at this point. And then we would loop back through here. And this time digit would now be 2, right? Because our number is 12. So now we have digit 2, and then we check that. All right. And basically, once we run through all the digits, so once number is no longer greater than 0, we've got to the end. So then if we get there, then all the digits did divide, right? We never hit this if case where we return false. So we made it all the way to the end, which means we can return true. All right, so the only other part of this that got me a little bit would be like if the number was 0. So if we look at our thing, the number is always greater than 0. All right, so I was going to say like we have to have a check maybe to say if it's 0, then we want to return false, but we're guaranteed that number is above 0. So like in my head, I could think like, does this still work for like 10? And I think for 10 it would. We'd get a 0 here, and then it would fail right away, which is what we want. So I think this is it. We don't even need to check if it's equal 0 because we know that according to this precondition, it's greater than 0. All right, so that should be it for part A. There's a separate video for part B. Hope that helped.